What language features eliminate null pointer exceptions today? Imagine a world where runtime crashes caused by null references are a thing of the past. Today, modern programming languages are making that possible by introducing features that prevent these errors from happening in the first place. Null pointer exceptions happen when a program tries to use a reference that points to nothing, leading to crashes that can be frustrating and time-consuming to fix. To tackle this, languages like Kotlin, Swift, and recent versions of C# have built-in tools to handle null values more safely. One of the most effective features is the use of nullable and non-nullable types. In Kotlin, for example, you declare variables as either nullable or non-nullable. If a variable is non-nullable, the compiler makes sure it can never hold null, catching potential issues before the program even runs. If it's nullable, you must explicitly check if it's null before using it. This static check helps prevent null pointer exceptions early on. Swift works similarly, with optional types that requiring you to unwrap values safely, ensuring you handle the null case properly. Another powerful feature is the use of optional or maybe types. Java introduced optional in version 8, which wraps a value that might be missing. Instead of assigning null, you use optional objects, forcing you to handle the absence of a value explicitly. This approach makes null handling clear and reduces accidental dereferences. Languages like Haskell use maybe types, which serve the same purpose by making the possibility of missing data explicit. Safe navigation or safe call operators are also common. Kotlin's operator allows you to access properties or call methods on nullable objects without risking an exception. If the object is null, the operation simply returns null instead of crashing. Swift's works similarly, making code safer and cleaner. These operators help you write code that gracefully handles nulls without cluttering it with multiple null checks. Null coalescing operators are another handy tool. In C, the operator provides a default value if an expression is null. Kotlin's operator does the same. For example, if a variable might be null, you can assign it a default value automatically, avoiding null pointer exceptions altogether. Explicit null checks are still useful. By using conditional statements or ternary operators, you can verify that an object isn't null before accessing it. This simple step can prevent many runtime errors and make your code more reliable. Some languages and frameworks also include static analysis tools. These tools scan your code for potential null dereferences and warn you before you run the program. This early warning system helps catch issues during development, saving time and effort later. Practicing these features and techniques can dramatically reduce null pointer exceptions. For example, breaking complex method chains into smaller steps makes it easier to identify where null values creep in. Writing unit tests that cover null scenarios ensures your code handles these cases properly. Proper initialization of variables and avoiding returning null from methods whenever possible also helps. By adopting these language features and best practices, you can make your code safer and more predictable. This not only prevents crashes but also makes debugging easier when issues do arise. Mastering these tools is a key step toward writing more stable, bug-free software.